Good afternoon. I want to welcome you back for yet another excellent lecture by Revd Dr Rodney Holder. Dr. Holder read mathematics here at Trinity College in Cambridge and then researched for his PhD in astrophysics at Christ Church in Oxford. He returned to Oxford to study theology and was then ordained in the Church of England in 1997. After several years of parish ministry, he was appointed the course director of the Faraday Institute for Science and Religion from its inception until his retirement in January 2013. Of course, Rodney has not fully retired. He's still working very actively in this intersection. He's explored ways in which science and faith complement each other in a number of books and in 2 Faraday papers, and he is a regular speaker on the relationship between religion and science, especially cosmology. He's a reviews editor of Science and Christian Belief and is on the National Committee of Christians in Science. In addition, he's a member of the International Society for Science and Religion, the Society of Ordained Scientists, and the Science and Religion Forum. This afternoon, he's going to talk to us about cosmology and the anthropic principle. Welcome, Dr. Holder.
Thank you. Well, thank you very much. So in this talk, I'm going to talk about these things, the specialness of the Big Bang, the so-called fine-tuning, and the meaning of this term, the anthropic principle, some examples of fine-tuning, asking whether there's really anything to explain, and then going on to possible explanations for this fine-tuning, going to some recent developments in cosmology, and then talk a bit about multiverses, which are often invoked to explain the fine-tuning, and compare the explanations. So the specialness then, and this relates to 2 kinds of quantity: the initial conditions right back at the beginning of the Big Bang, some 13.8 billion years ago, and the physical constants that go into the laws of nature, the strengths of the fundamental forces of nature, masses of the fundamental particles, and so on. Now, in the literature, the term anthropic principle is widely used to denote the constraints on the laws of nature which are required for us to exist. It comes from an original paper by Brandon Carter, back in the 70s, and another early paper was by Bernard Carr and Martin Rees. And then perhaps the classic book on the subject is the Anthropic Cosmological Principle by John Barrow and Frank Tipler. It's a bit of a problematic term, though, for several reasons. One is that, of course, the term is derived from the Greek word anthropos for man or human person, Adam, in Hebrew, and of course the conditions that we're talking about here are really the conditions for anything interesting to happen at all in the universe, basically. I mean, perhaps the conditions for life, but and indeed the conditions in some cases for anything interesting at all. So not necessarily for man. So Paul Davies, for example, prefers the term biophilic universe. Why is the universe friendly to life? And then the second reason why it's not perhaps the most helpful term is that it is used in a number of different ways, in some of which are basically tautologies, and other ways which are, sound like speculative metaphysical principles. So here is the weak anthropic principle as defined by Barrow and Tipler. The observed values of all physical and cosmological quantities are not equally probable, but they take on values restricted by the requirement that there exist sites where carbon-based life can evolve, and by the requirement that the universe be old enough for it to have already done so. Well, this probability that's being talked about here, the probability that these quantities take the values they do, is clearly not the a priori probability, which could indeed be very small, but the a posteriori probability, given the conditional probability, given that we exist, well, clearly given that we exist, not every value of any old value of any constant will do. So, it's in that sense, then it's almost tautological. Then there is the strong anthropic principle, which in Barrow and Tipler's framing of it is that the universe must have those properties which allow life to develop within it at some stage in its history. Well, again, it's a bit ambivalent, because what does this word must mean? Well, given that we're here, of course, the universe must have those properties which allow life to develop. But again, must in the sense of, the universe couldn't be any other way, would be a highly speculative idea, and indeed would virtually lead into the participatory anthropic principle, the third one, which basically says observers are necessary to bring the universe into being. So essentially, as observers, we create the universe. Now, if that sounds paradoxical, well, again, it is paradoxical. But you can see where some people who get this idea from, John Wheeler in particular, I mean, some very clever people, it has to be said, Nobel Prize winners and the like, get this idea from, is from quantum theory and the Copenhagen interpretation thereof, whereby we bring about a particular state of a quantum system by making a measurement. But whether we bring the universe into existence or whether the universe brings us into existence, I think is pretty controversial, to say the least. So in general, I try and avoid this terminology. I might talk about anthropic, use the term in, more generally, but given the ambivalence of the term anthropic principle, I tend to stick to fine-tuning as what we're talking about here. And I'm going to give you a few examples of what's meant by the universe being fine-tuned for life. So here we are, 1 second after the Big Bang, the mean density of stuff, of matter energy in the universe needs to be what it was to 1 part in 10 to the power 15, one with 15 noughts after it. The universe is actually on a knife edge. If we take the classical cosmological models, on a knife edge between expanding forever and ultimately recontracting. And that's all to do with how much stuff there is. If there is less matter energy than there was by this tiny, tiny amount, then the universe will recollapse. Will expand. If it's less, then gravity won't be sufficient to pull it back. It will expand forever, but expand far too quickly for anything interesting to happen, like galaxies and stars to form. And then if it's overdense by more than this tiny amount, then gravity will pull it back very rapidly, and there will be no time for anything interesting to develop. And you can track back even further than this. If you go back to that earliest period that it's possible to speak of, 10 to the minus 43 seconds from the Big Bang, when we need a theory of quantum gravity, tiny, tiny fraction of a second from the Big Bang. If we sort of just extrapolate back from there, then this mean density needs to be right to 1 part in 10 to the power 60. So that is, well, incredible fine-tuning. It's the same kind of accuracy you'd need to fire a gun at a coin situated 13 billion light years away, the opposite side of the universe. Then the weak nuclear force that's responsible for radioactive decay and the gravitational force are related in a particular way. The gravitational force is the weak force to the power 4, roughly speaking. Well, pretty accurately speaking. And if it were ever so slightly different, then you would get all the hydrogen in the Big Bang converted into helium. And that would be a problem. Because then if you've eliminated all the hydrogen from the universe, there will be no possibility of creating water later on, of water coming about, which would seem to be necessary for life. And this this relationship gets constrained both ways by the necessity for the first stars to explode as supernovae and so on and make the chemical elements they've made available for subsequent generations of stars and ultimately planets. Now, one of the most important elements, well, hang on. Oh, yeah, no, sorry. Next one, strength of gravity. Now, it could be more than it actually is. It could be maybe 3,000, up to 3,000 times its actual value. Life starts to get pretty difficult if you just simply increase the, go on increasing the strength of gravity more than that. I mean, we would be weighed down. We'd have to be much smaller to subsist on a planet our size. Then you could alleviate that by having smaller and smaller planets, but then you'd have no sustainable ecosystem and so on. So you soon hit problems. But in principle, gravity could be maybe 10 to the 40 times its actual value. So just naively, the probability that it takes a value within the allowed range would be 3,000 divided by 10 to the 40, 3 times 10 to the minus 37. Tiny probability that given the possible values of the strength of gravity, it takes a value that's compatible with life. Here's another example. There's a tiny excess, 1 part in a billion, of matter over antimatter. And if there weren't an excess of about that amount, then there would be no matter left over in the universe. You'd get matter annihilating the antimatter and so on, and just radiation. So that seems to be another significant element of fine-tuning. Now, as I'm going to say later on, we might get better theories which somehow explain why there's an excess. But then you have to ask yourself, well, why are the laws of nature set up in a special way that it leaves that excess? You're basically moving this question up a level. So one part is then this is an extremely significant one, the value of the strong nuclear force, the force that's responsible for nuclear fusion. So in the Big Bang, you get hot temperatures, very hot temperatures in the first few minutes of the universe's existence, and nuclear reactions can occur. But all that gets made is helium. In fact, there's a nice synthesis between what gets created in the Big Bang and what gets created in the cores of stars, where you also get very, very high temperatures, billions of degrees, in the cores of stars, where also nuclear reactions can occur. But we couldn't work out how to get beyond helium made in the Big Bang, perhaps a little bit of lithium, but not much further in the periodic table. But in the cores of stars, we couldn't see how all the helium, I mean, hydrogen does get converted into helium, but not to the 25% that's actually existent in the universe. So there's been this nice synthesis of where the elements are made. But anyway, inside stars, all the other chemical elements are built up through further nuclear reactions. So to make carbon essential for life, what you need to do is crash 3 helium nuclei together and get them to stick. And the problem is that it's very difficult because the intermediate element with 2 helium nuclei crashed together, beryllium, is unstable. Beryllium nucleus only lasts for 10 to the minus 17 seconds. You've got this split second to crash the third one on. And it needs an enhanced effect for that to happen, something called a resonance in the carbon atom, the result of this reaction, for that one to go. And then to make oxygen, what you need to do is to crash a further helium nucleus onto the carbon, but of course you don't want to turn all the carbon into oxygen if you're going to have life in the universe. So you don't need a resonance, a similar effect in the oxygen atom. So the interesting thing about all of this, particularly interesting thing about this, is that these coincidences were discovered by none other than Sir Fred Hoyle, the proponent of the steady state theory I mentioned in my previous lecture, who was an atheist cosmologist. I was in Belfast a couple of years ago, and my wife's Irish, so and I asked her whether I could tell this particular story, and she said, yeah, it'll be okay with this audience. Fred Hoyle described religion as an illusion in broadcasts on the BBC, and he said he would solve the Northern Ireland problem by locking up all the Catholic priests and all the Protestant ministers, because they were all teaching nonsense to their congregations and teaching different nonsense. I got away with it, I have to say. I think they saw the amusing side of the Hoyle quote. But anyway, having said that, when Hoyle discovered these coincidences, seeming coincidences inside stars, he was moved to remark that a super intellect has monkeyed with physics as well as with chemistry and biology, and there are no blind forces worth speaking about in nature. The universe is a put-up job. Otherwise, you're just left to some monstrous sequence of accidents. So he was moved to talk about a super intellect behind the universe. Well, of course, he couldn't quite bring himself to use the word God at this point, but, well, what is a super intellect behind the laws of nature? Now, there are lots more examples of this sort of fine-tuning, which I can't possibly go into, but I'll come back to one or two more later on. Now, this is what Paul Davies says about it, who's a very eminent cosmologist. He says, like the porridge and the tail of Goldilocks and the three bears, the universe is just right for life in so many intriguing ways. So he's certainly someone who thinks that there is something here which needs to be explained. And let me go on and ask, well, is that so? Is there really anything to explain, or how might one dismiss all this and argue that, well, you know, there isn't really anything here? Well, one way is by the approach of Richard Feynman here, who Bob mentioned earlier on, great physicist. He was looking out into the car park at Caltech one day, and he said, well, he saw this car, Tennessee number plate ARW 357, and he said, wow, isn't that utterly improbable? But to see that particular number plate. And of course, any other number plate would be equally improbable. And so, well, any set of constants, okay, it's improbable, you know, but that's the way it is. But one could tell a different story. At school, I had a teacher whose name was A.R. Wheeler, and he was born on the 3rd of the 5th, 1907, and he collected vintage cars. And one day I saw a car in the school car park with the number ARW 357. Now, would that be at all surprising, you see? That would then be a meaningful number plate. And similarly, I think the point is about this universe, the constants, well, they might, any set of constants might be equally probable, but the trouble is, or equally improbable, but the trouble is this is a meaningful universe. And it seems that in a meaningful universe, we need a better explanation than that it's just some random phenomenon, I think. Here's Richard Swinburne, a famous Oxford philosopher of religion, professor at Oxford for many years. And he postulated this mad scientist with a machine which shuffles 10 packs of cards simultaneously, and the and unless all the 10 packs that you keep turning out aces, the machine will blow up, and you'll just be obliterated. But in fact, the machine does keep turning out aces, and lo and behold, you are alive and wondering, well, is it just well, what was it, 1 in 10 to the 60 for each pack, time after time? Is it so immensely improbable, or is there another explanation? In other words, he's kind of rigged it. Here is a firing squad. This is an example of the philosopher John Leslie. This poor fellow, he's got 50 sharpshooters against him, and they're all about to fire. He gets blindfolded, and then they shoot, and then, he's still alive. Takes the blindfold off, here he is, still alive. Does he just shrug his shoulders and say, all their guns jammed, and it was all an accident, or, they just, they were not very good at aiming and so on? Or does he say, actually, it was rigged? They deliberately fired over my head. They didn't want to kill me. There was something else going on. So it was not it wasn't his 1 in 10 to the 60, 10 to the 50 or whatever. It wasn't, the immensely improbable on this hypothesis. Here's another example which I sometimes use. Suppose I shuffle a pack of cards and I deal this perfect hand for bridge. If it is a perfect hand for bridge, it depends who gets what, I guess, and then how the bidding goes. But you can get 4 spades, I suppose, and yeah, but it depends who. No, maybe it doesn't work. But anyway, suppose you shuffle this pack of cards and it comes out like that. Now, of course, there is a very, very tiny probability, 1 in 10 to the 68, I think I calculated, for this hand to come up. And of course, that's just as improbable as any other hand. But if you realize I'm a card sharp, then maybe you start to get another idea that it's not just been dealt randomly, but that I'm a cheat, and I've rigged it. Well, I think that when you translate this to the universe and argue that, well, actually this isn't any old universe, it's much more like a perfect deal of cards than it is like what you would see as a random organization of these cards, which you'd get more typically, even though just as improbable. But it calls for a different explanation than, well, just shrug your shoulders, you just got lucky, it seems to me. So when we go on to look at what the explanations might be, well, Paul Davies, of course, certainly thinks that there's something to be explained. My own inclination is to suppose that qualities such as ingenuity, economy, beauty, and so on have a genuine transcendent reality. They are not merely the product of human experience, and that these qualities are reflected in the structure of the natural world. So by way of explanation then, well, we could say God set it up that way. It was designed, and maybe for believers that's a rather natural conclusion to draw. But if we're, certainly if we're in the academic world, we need to try and discern what alternative explanations there might be and see what alternative explanations people have come up with. So I'm going to suggest 2 diametrically opposed explanations. One is to say that actually, I'm mistaken. There is only one self-consistent set of constants for the laws of physics, or maybe even there's only one self-consistent set of laws of physics with unique constants. And so in saying that there's some kind of distribution from which the probability distribution from which those numbers can be drawn, that's wrong. They have to take certain values. And Einstein himself was looking for a so-called theory of everything in which, and he asked about it, whether God could have made the universe in a different way. Well, of course, it doesn't do away with the cosmological argument, the need for God to create the universe, but it restricts God's choice, if there's only one possible way of making the universe. The second strategy is to postulate the diametric opposite. Yes, all these constants can take different values, and indeed they do in lots of different universes, a so-called multiverse. And then we are meant to say, well, all the values of the constants exist in some universe. That explains why why our universe exists and why the constants take. We couldn't exist in any of that vast number apart from this tiny subset in which the constants are just right. Now, I think there are problems for both these explanations, as I shall explain. Well, of course, if with the first strategy we're saying that only one set of constants for our physical laws is possible, there might still be other laws, and then you'd have to ask the question, well, why do our particular laws apply? But if there's only one self-consistent set of laws in the first place, well, that would do the trick, but it would leave one with an incredible puzzle as to why the only set of self-consistent laws gives rise to life. That would be deeply puzzling, given that we can imagine all kinds of worlds, and we don't see any contradiction, really, say, for a world in which all there is a few particles floating about in otherwise empty space, or just a single lump of rock surrounded by a void. Well, there doesn't seem to be anything self-contradictory in those universes. So why it gives rise to life would be deeply puzzling. And for the second strategy, well, you'd have to ask, well, why this multiverse as opposed to another? Because you'd still have the question, well, there are lots of different ways of assembling a multiverse, a collection of universes, even infinitely many universes. And you can always add to an infinity and so on. One cosmologist, Max Tegmark, has gone to the ultimate extreme and said that any set of physical laws has, any set of mathematical laws has physical existence. That's pretty metaphysical. How we could ever test a hypothesis like that, I really do not know. Let me go back to some science for a minute. Let's see how science has attempted to, well, has really rather oscillated between these different strategies, not necessarily for atheistic reasons, but it certainly seems to have oscillated. This is a chap called Alan Guth who came up with a theory called inflation, which is an early rapid period of expansion. You've got time on this axis. In the first 10 to the minus 35, 10 to the minus 32 seconds, something like that, the universe underwent an incredibly rapid expansion. And then you just had the steady, normal Big Bang expansion, starting to accelerate again here, which I might come back to in a minute. And that early rapid period of expansion drives the universe to uniformity. It actually fixes at least one of the parameters that I've talked about, the mean density of stuff. That's driven to this critical value. The problem it was with the original version, at any rate, that it needed fine-tuning itself. So this seems to me to be a kind of repeated phenomenon. You get a better theory, perhaps, but that theory needs fine-tuning. You know, you can always ask why the theory of inflation, with the properties that it has. Why does inflation cut off at just the right moment, for example? So people have gone, Guth and others have gone to, Andre Linde in particular, in Stanford, have gone to multiverse versions of inflation, chaotic and eternal inflation. These are multiverse versions. So you have of an overarching space. They're called different universes, even though really they're part of the same overarching space. And in some parts you get inflation, universes bubbling up, and at different rates. Other parts you don't get inflation. And then out of these bubbling up universes you get more and more universes bubbling up. Another development has been so-called string theory. Here's Leonard Susskind, a pioneer I had the privilege of debating with a few years ago in Stanford. He says that matter comprises tiny vibrating strings. Well, that's what string theory says. And M theory, that you might hear about, Stephen Hawking favors it, is a generalization of string theory. Now, it was originally meant to be the theory of everything, if you like, the theory that calculated all the values of the constants and the masses of the particles and so on. But after 40 odd years or whatever, it hasn't made any predictions of that kind. So Susskind and others have moved to what they call the landscape of string theory, which is a multiverse version of string theory, in which there are maybe 10 to the 500 solutions of the theory, all of which get instantiated in different universes. And you can marry that theory with inflation and come up with at least a coherent theory, but whether it, well, the question arises as to whether there's any evidence for it, and there are also alternatives. I haven't by any means exhausted some of the theoretical offerings that there are out there at the moment, not all of which are compatible. Now, and that fact has led this particular character, Lev Landau, Russian Nobel Prize winner for physics, to say that cosmologists are often in error but seldom in doubt, which is perhaps a rather fun quote. Now, I know I've only got 9 minutes, so I'm going to run through what I see as some of the problems for multiverses. Now, first of all, the physics is speculative, certainly with theories like string theory. You may hear more about this from Paul Shellard later in the week, who's who's a professional cosmologist today, working in Cambridge with Hawking and others, same department. Anyway, we are talking about a realm, 10 to the minus 43 seconds from the Big Bang. We can track back the history of the universe with physics we know about. I've talked about the first few minutes when nuclear reactions were going on. You can track back further than that. The era when the Higgs boson was around, which has been discovered in CERN, 10 to the minus 10 and maybe further back slightly, seconds from the Big Bang and so on. 10 to the minus 12. Anyway, you can track back a bit further, but 10 to the minus 43 seconds. And to create the energies required at that sort of epoch, you'd need an accelerator, not the 17 miles or kilometers of CERN, but the size of the galaxy or something. There is a problem about infinities. I mentioned some of the sort of paradoxical things to do with time in my last lecture. There are paradoxes of physical spatial infinities, if you like. I won't go into too much detail, but for example, the mathematician David Hilbert had a hotel. He ran a hotel which had infinitely many rooms, and they were all full. So a new guest came along one day, and Hilbert scratched his head and he said, well, how can I fit this person in? Okay, I'll move the person in room 1 to room 2, the person in room 2 to room 4, the person in room 3 to room 6, and so on and so on. Lo and behold, all the odd numbers rooms are full, but all the even numbered rooms are full, all the odd numbered rooms are free. Room for infinitely many new guests. So you can never complete an infinity. You can never guarantee that even with infinitely many universes, you've covered all the possibilities. There's a problem about human identity where, well, this lecture is duplicate. As soon as you go off into the infinity, everything, however utterly improbable, even if it has a tiny positive probability, gets replicated. And it gets replicated infinitely many times. So you find there are infinitely many replicas of this room with this lecture going on, but in some of which I thought, goodness me, I've had enough. I really am retired. I mean, 2 lectures in one afternoon. But anyway, so I don't come along. Others I'd sort of drop down dead halfway through. I hope that, well, more than halfway through, I've managed to escape that one. Not in that universe. And so on. You know, you get this. It doesn't defeat the idea. But if you can have a theory which isn't quite as paradoxical as this, maybe you should go for it. For the sort of reasons I've been saying, it isn't a simple hypothesis. You're multiplying entities against the William of Occam's principle, Occam's razor, to the ultimate degree, it seems. Whereas in science, one normally goes for the simplest of competing hypotheses that actually cover the data. And you could end up with strange features in your laboratory which you would normally want to try and explain within the tenets of normal science, but if we're in a multiverse, well, anything can happen. Anything that everything that can happen does happen somewhere, sometime in some universe is the mantra. And that can lead to, if you like, a multiverse of the gaps. We heard a bit about a god of the gaps earlier on, but a lack of predictability and a lack of, a disincentive to do what I'd call normal science. The cosmological constant is something which Einstein originally introduced into his equations in order to give the solution which is static, with an infinite past and an infinite future. When the expansion was discovered, he dropped it altogether, and he's said to have remarked that it was his biggest blunder. Nevertheless, it's come back in, and I mentioned the expansion of space expanding when I showed that diagram of inflation. The expansion is accelerating. The expansion is accelerating, and that's due to a very small value of this thing called the cosmological constant. The trouble is, it takes a value that's 10 to the 120 times too small compared with calculation. Calculations of what this value should be, it's called the vacuum energy, turn out to be 10 to the power 120 times too big. And that's a massive problem, because I mean, it certainly couldn't be anything remotely like that. It can't be much bigger than it is in order to be compatible with life, or with galaxies forming and with life forming. If it were anything like 10 to 120 times that value, it would, well, our bodies would fly apart in a split second to opposite ends of the universe. I mean, we couldn't be here in the first place, but if we were, then that's what would happen. For some of these multiverse models, fine-tuning is needed anyway. You need, in order to get an infinite universe, you need, and generally we're talking about infinite universes, but in order to get one, you need the mean overall density of stuff in the universe to be less than the critical value I was talking about, and that may well not be so. There's some fine-tuning required for that to happen. And then there's the amount of order in the universe. Oh, I'm running rapidly out of time. Roger Penrose has argued that the universe starts off highly, highly ordered. I mean, if I were to knock this glass off the table, you would see it might smash on the floor, water spread around. You don't see glasses lifting up back onto tables and the water coming back into them and so on. That's either a Harry Potter film or the film running the wrong way or something. But the universe is going from a state of order to disorder. And Penrose calculated that the creator, metaphorically speaking, had of the order of 10 to the power 123 possible universe configurations to choose from, only one of which would have the order and structure that ours has, out to the furthest galaxy that we can see. The problem is worse than that, because that's fine-tuning, but maybe you could get around that with a multiverse. Well, if there are 10 to the 150 universes, maybe some would be like this. The problem is that the vast majority of them would be, of the tiny subset that had life, the vast majority of those, even though a tiny subset, would not resemble this universe. They'd be much, much less ordered. They'd be much more like a single solar system surrounded by junk, because a single solar system gives you enough structure for there to be life in the universe, rather than the 100 billion galaxies worth of order that we see. Then there's a problem with fake universes. In a multiverse, simulations of universes like the Matrix tend to multiply. Don't want to dwell on that because I'm hitting for my time. So I think the theistic explanation, really from the last lecture, it provides the ultimate explanation for why there's a universe at all. And it does explain why there's life, because God had intentions and purposes for there to be life in the universe, and ultimately intelligent life, something like ourselves. And God freely chose to create this particular universe, intending that it produce intelligent creatures. And God is more likely to make a wholly ordered universe rather than a single solar system surrounded by junk. And end with a quote from my hero, Georges Lemaitre. In fact, last year, it's worth noting that we celebrated or commemorated the 50th anniversary of Lemaitre's death. And he heard on his deathbed the news that the cosmic background radiation had been discovered just as he was about to die, which was a rather lovely thing. But at one point he said this: there were two ways of arriving at the truth. I decided to follow them both. And I think that's a rather wonderful quote for science and theology. Okay, I'll stop at that point.
Thank you very much. That was a really thought-provoking lecture. And now we have time for an infinite number of questions.
Thank you, that was really interesting. Am I right in saying that what you've presented is an elegant version of the argument for design, or
Yes.
from design?
Yes.
And is it not therefore subject to all the critiques that the argument from design has?
Well, yes. I mean, one would perhaps need to go into some of those arguments, going back to Hume and Kant and so on. I think one of the arguments, for example, against there being, Hume had, for example, a ship and lots of people working on it, and whereas I think this, if you look at the universe, it does speak to there being a single creator behind it, rather than multiple gods, for example, working on different bits, because we see uniform laws across the whole of space-time from that first fraction of a second to the present day. In fact, that's a wonderful, if you like, for me, witness to there being one creator. So, and if we go into the probabilities about this as opposed to design, as opposed to God, and use, I've in my various more technical things, I've looked at it using Bayesian probability theory. Then I think the design argument comes out well. I think it comes out pretty well. I mean, you're more or less. It seems to me if you're an atheist, you're almost forced to say that the concept of God is incoherent. I mean, it has to. If you take the argument from Penrose, it's almost the probability that of God existing has to be something like less than 1 in 10 to the 10 to the 123, which is almost like saying it's incoherent. So I think it does stand up to sort of traditional type of criticisms.
Okay, how about here? Hold on.
Thank you. Even if it was the case that multiverses exist, that wouldn't necessarily rule out God.
No.
But Dawkins says there might be like a Darwinian explanation for the universe, just as was for biological life.
Yes.
Is it the case that there is an evolutionary mechanism?
It does seem to me a misapplication of something from the biological world to physics, which works on different principles, really. I mean, well, let me go back to the first part. Of course, God can create as many universes as he likes. And of course, there are some Christian theologians, philosophers, scientists who are perfectly happy with the idea of a multiverse. And I could name some of them. Arthur Peacock, for example, one of the pioneers, along with John Polkinghorne, of this modern science-religion dialogue, would say, well, as long as the multiverse has, it allows for cognizing subjects, is this way of putting it, then that might well be God's way of doing it through a multiverse. That's perfectly fine. Robin Collins, a philosopher, says that a multiverse would be perfectly acceptable. But there would need to be a multiverse generator. You'd need the right kind of multiverse. So again, you're always sort of shifting the problem up a bit. Keith Ward, who's a theologian in Oxford, says that, multiverse is perfectly fine, but as long as that doesn't allow for universes with overwhelming quantities of evil to exist. Now, if we think there's a problem of suffering and evil in this universe, we can imagine those that are, that are vastly worse. Of course, none of these scientific models, deal with that at all. I mean, but in principle, if you go down the route of there being infinitely many, then and they're just on the basis of kind of random probabilities, but everything that can happen does happen somewhere, sometime, then you would end up with some pretty evil universes. Going back to the whether they evolve or not, there is one there are some speculative models which sound a bit like an evolution. Elise Smolin has a model whereby black holes spawn other universes. They pop up at the cores of black holes and go into another. Well, they kind of somehow break off. The space-time breaks off, and the universes that propagate, they tend to propagate in ones that have more black holes. Well, and again, that all seems a bit problematic to me, I have to say. Because in general we think of black holes as being destructive, and they contradict what Penrose says about the entropy of the universe at the beginning, the high state of order. It had to be highly ordered in order for everything not to go into black holes. So, but anyway, there are, and then some of these fake universe type ones, but simulations. Well, as soon as civilizations arise, they learn how to create universes. But of course, it's much easier to create simulations of universes than real universes. So the simulations tend to proliferate. So in that model, it's the fake universes, the ones that are simulations. Are we in a real universe? Are we in the Matrix? What are we? Where are we? It's those types of universes that proliferate rather than real ones. So there are. I mean, it's different. I'd call it different from biological evolution, but there are some kind of speculative models of that kind. Maybe that's enough on that.
I believe you mentioned that the two necessary elements for the Big Bang theory are carbon and oxygen, or helium. Is that right?
Carbon and oxygen. Yeah.
So does that, because that would mean that there's a more progressive sort of creation, does that invalidate the belief of some people that Genesis is to be taken literally? And I guess my second question is, where are all the female scientists? Because throughout the course of today, there has not been a single
Not my fault. We should have had Jennifer speaking. We have many times. And she's a practicing modern day cosmologist, astrophysicist. So, apologies for that. Put it on the feedback form about the women scientists.
Janet couldn't come.
Sorry?
I don't mean speakers. I mean mentioned.
Mentioned in the history.
Yeah, I don't mean
Oh, sorry, you don't mean in the course.
No. I was saying that throughout the course of the day there has not been.
Well, I noticed. Yes, there was one woman on Bob's, if you remember, Dorothy Hodgkin. Did you see Dorothy Hodgkin on Bob's slide? Yeah. Very significant Nobel Prize winning scientist. Yeah, very fine. Yeah, my talk, I've mentioned largely men, haven't I? Okay. Jocelyn Bell Burnell, who is the lady who missed out on the Nobel Prize because her supervisor got it. I mean, she was a PhD student here in Cambridge and discovered pulsars.
Well, let me
yeah.
rescue you a little bit here.
Yes, thank you, Jennifer. Yes.
It is the case, this is a sociological issue, that
Yeah.
many voices of humanity don't often get heard about or discussed, or many peoples haven't had the luxury, actually, of being able to think about these deep existential questions in a way that gets transmitted to other peoples and cultures. So that is an unfortunate, matter of human existence right now that we are hopefully all collectively working on. So there are many actually voices of other cultures and of women who are out there. They just need to be brought forth into these conversations a little bit deeper. And so you are here, so you can become one of those voices.
And
yes.
I think it is changing. Of course, I mean, a lot of the talks are historical. I mean,
Yes.
and you just have to look back and before women were really, I mean, you could only get a degree in Cambridge. I mean, this is a terrible thing to truth, I'm afraid, in Cambridge in 1948. I mean, there were women, they created ladies' colleges in the 19th century, but not allowed to graduate properly until. Anyway, but there, and I mean, the head of the Cavendish at the moment is a woman, Dame Athene Donald, and so Mary Fowler was mentioned earlier on, descendant of Rutherford. Principal of Darwin College. So there, in the present day, I think things are certainly changing. But there may well be difficulties that women face that men don't in their careers, which make it still imbalanced. Anyway, that's enough on that perhaps. But the early one about Genesis, well, I mean, we are dust, but we're stardust, which is, I think, an actually wonderful thought. We are made from the ashes of dead stars. That's almost a cliche in astronomy today. The supernovae that explode and spread out all the chemical elements that have been made in their cores then go into the planets and ultimately life. So when I spoke about a literal interpretation of Genesis in my previous talk, and I think, well, that's not the way I read it, and I think it's a mistaken way of reading it in its context.
Let me just follow on something Rodney said. I think this would also be a very good topic for these evening discussions, which is, are there voices and perspectives on this interface of science, religion, and the meaning of life that are not brought up because we haven't heard those voices as much throughout history? How do we, would those perspectives help enrich and balance these conversations better? What kinds of perspectives are we missing? What can we do to get a better sampling of the human experience and the kinds of questions that all kinds of people have that touch on the interface of science and religion and these topics we're talking about this week? So I would love to hear some of that conversation in our evening panel discussions as well. So I bring up a good point. Okay, more questions. How about, there's a couple on that row back there, so.
Thank you. This relates in a way to a question that came up this morning, this enormous amount of creative activity that has gone into the universe, and that's even if there's only one universe, let alone multiverse, if God's sole purpose is the creation of man.
Yes.
We would presumably say that in principle, if God had wanted to create just an Earth or just a solar system, he could have created man that way. But given that there is this enormous expanse of the universe, both in space and in time. In your understanding, what does that tell us about God's relationship to the whole of his creation, both in his act of creation and indeed in his act of incarnation?
Yeah, well, I think I think God glories in his creation, and his glory is shown in the creation. I think I quoted Psalm 8 in my previous talk, and the heavens declare the glory of God, Psalm 119. So, yeah, and I think the size, the splendor, the magnificence of the universe with the 100 billion galaxies or more is a sign of the majesty of God. So I think there's that. And then on the question of is it all just for us? Well, of course it has to. I mean, as I was saying, it does have to be pretty much set up in this way, and it has to be as old as it is and as large as it is for life to exist. But that's not to preclude there being life elsewhere. And then the question arises as to whether God becomes incarnate or can become incarnate in other life forms, in other intelligent life forms, I would say, in life forms that have the sort of capacities that we do, and capacities for making moral choices and so on. So, and of course, one of the things Jennifer has been involved in is looking for exoplanets and this extraordinary work, finding the slightest wobble in a star that indicates that it's got a planet in front of it, and working out the size and so on, and whether it's in the Goldilocks zone, all that stuff. That's creating certainly an interest in the possibility of there being life elsewhere. I mean, we haven't detected any life elsewhere, but it raises the possibility that there could be, given that we are now finding more Earth-like planets. And then I think the main question, certainly for Christians, would be to do with the incarnation, and whether the incarnation of God on this one planet is enough, or it saves the whole universe, or whether God shows himself to other creatures. The puzzle would be if God were only incarnate here and there were other intelligent life forms, then they would be without the kind of knowledge of God that's been given to us directly through the incarnation, the revelation of God in the person of Jesus Christ. Seeing Father Javier here reminds me that the astronomer, the Vatican astronomer, has written, Guy Consolmagno has written a book called "Would You Baptize an Alien?", which I think is a wonderful title for a book. And,
To which his answer is,
I think it's yes.
only if she asked me to.
Oh, well, yes.
He got that question as an email. He gets lots of emails because he's a Vatican astronomer. That was a real question that he got, and that was the real answer.
Yes, yes.
But it's the whole book is quite interesting. So I have a question.
Oh, right, yes.
So this whole discussion was kind of introduced through the Anthropic principle and through fine-tuning, like this uncanny sense that the physical constants of the universe are finely tuned to produce life. Why is that? And so for some that looks like it really is evidence for God, and for others that concept is so uncomfortable that they would like to search some other concepts. But my question is, what if, just hypothetically speaking, science showed us just the opposite, that in fact, incredibly, no matter that the fundamental constants of the universe we find out could be a huge range, and the universe would still produce life that is robust for life, no matter what these constants would be. Wouldn't there still be that same philosophical interpretation choice, whereas some would say, well, that means that God created this wonderful universe that was inevitably suited for life no matter what those physical constants were? whereas others would say no, life is just random. I mean, doesn't this come down, no matter what the physics says, to a philosophical argument of interpretation?
Well, yes. No, I don't think that's the world we're in. I mean, actually, interestingly enough, if you go back 40 or 50 years, you had an idea called chaotic cosmology, which attempted to show that the universe, however the universe started, it would end up, well, isotropic, looking the same in all directions and so on. And that would be a universe in which life could develop. And Stephen Hawking, interestingly, and a colleague showed that that was false, and they had a paper in which they showed that the probability of life evolving from random starting conditions was actually 0. So it does seem that we're in a special universe. And people have done, I mean, you know, the whole kind of discussion, you have to inevitably say...
I think you're right. This is the universe
Yeah.
we live in. I was just saying, hypothetically,
Yeah, hypothetically,
speaking,
yeah,
could
yeah,
it be
exactly.
the other way, and would the
And
arguments
then
go
would the argument... So suppose the universe could start any old way. Well, I suppose what that would do would remove one... what would that do? That would remove the fine-tuning puzzle. But I don't think it would remove the puzzle as to why there's a universe, ultimately as to why there's a universe with intelligent creatures in it.
I think my question is really hinged on the fact that the whole fine-tuning business wasn't really discovered or discussed until recent scientific history, and yet, you know, there were theological debates and philosophical differences of opinion of purpose long before that. So these whole philosophical arguments don't necessarily hinge on this discovery of fine-tuning.
Well, I mean,
right.
but I'm producing a particular argument based specifically on fine-tuning, of course. But I mean, one of the interesting things I find about fine-tuning is that it's something that's come directly out of cosmology. It's come from cosmologists. And it's come from cosmologists with absolutely no theological axe to grind. Right. Brandon Carter is an atheist, the person who came up with the idea in the first place. And Martin Rees, who co-wrote another fine paper with Bernard Carr, is also an atheist. It's something that has, you know, arisen within cosmology and puzzled cosmologists. So that's, I think, where, for example, it differs fundamentally from intelligent design in the biological sphere, which has no traction with biologists whatsoever, you know, completely different kettle of fish. So this kind of design argument does seem to have traction, and some people are pretty explicit about why they go for the multiverse. Martin Rees is a case in point. He goes for the multiverse because he doesn't like the idea of needing to invoke God. However speculative, I mean, Martin Rees is interesting because in one of his books he writes how he's a cautious empiricist. He only believes the science from the first thousandth of a second, I think, from the Big Bang, when we're pretty, well, that sounds pretty incredible. But you know, we know the physics from that period, and he's a cautious empiricist. But then in another place he says, you know, about fine-tuning, his book, I think it's in his 6 Numbers book, which we've got out there, that, you know, he deliberately opts for a multiverse, which is a highly, highly speculative idea, because he doesn't want to invoke God. When there are others, I say, you know, Bernard Carr opts for a multiverse. He's not really. He's more theistically inclined, or perhaps Eastern religion inclined. He's certainly not anti. But others, you know, believe in multiverses who are theistic. So there are a range of opinions.
Okay, more questions. We've got somebody in the very back row there on that side, and then a couple on this side. So let's keep wanting to say the person with the red lanyard, but you all have red lanyards.
You talked about there being lots of speculative theories now, and you said to some extent we'd need to build a particle accelerator the size of a galaxy. I suppose my hopefully not too ignorant question is, it feels that physics has moved on a long way in the last 100 years, but crudely, although you can fine-tune the science, when it comes to some of these beginning of universe questions, are we now effectively stuck?
Well, I hope not, because I hope we can make more progress. I think string theory, which I've mentioned, has had a lot of the running in all of this. But it's not the only theory out there. And there are other theories which, loop quantum gravity and so on, which haven't been given quite the same run for their money. So, there may be, I mean, I think what they really do need to come up with is some kind, is observation, or maybe they need to detect some, superparticles or something that are predicted by the theory. So far, at any rate, the answer, there just hasn't been anything that's been confirming. So for them to, for these speculative theories to stop being speculative theories and bordering on metaphysics, but to be real physics, they need to make predictions, need to go back to the, the founding of the Royal Society that Bob talked about, and the need for experiment to verify the predictions.
Okay, we had a couple of questions over here. Can you raise your hands again, because I forgot who asked the questions. There were two.
Thank you.
Okay.
So thank you, Rodney, for your terrific talk. And well, I'd like to do two questions. So first, classic philosophy would distinguish between necessary beings and contingent beings.
Yeah.
Necessity and contingency.
Yeah.
So aren't we asking too much to scientific enterprise when we are looking for the ultimate reason for some equation for a theory of everything? Do you think it's possible to reach a theory of everything with an equation with this necessary? I think that's beyond scientific enterprise. Is it not the point at which science itself opens to philosophy or theology?
Yeah.
My second question, if I can, is I don't know whether people understand the degree of specialness of the fine-tuning.
Right.
So it's not a fine-tuning necessary for life. It's much more than that. So for having life, excuse me, but you don't need much. You need a solar system, basically.
Yeah.
That's very cheap in terms of statistics, So this number of that you mentioned, Penrose, this number is huge.
Yeah.
It's absolutely different. It's a different scale in comparison with what you need for life. So the degree of specialness of the universe is not for life, but for the development of the universe in itself, for entropy, for having the second law of thermodynamics. So I think we are dealing with something different for the typical biological question of design.
Okay, thank you. Yes, I think I agree with the second point.
A minute and a half. Can you do this?
I think I agree with the second point. So, but now then, whether we'll come up with a theory of everything, and the relationship with the necessity and contingency. Well, there's this cartoon I saw somewhere recently of this man on his sofa with his wife next to him, and he was looking at the TV, and Stephen Hawking said, "I've given up on coming up with a theory of everything," and the wife I'm never going to write down a single equation to describe the whole universe. And his wife said to him, "Well, that's something you've got in common. He's got in common with you." Anyway, so I think I tend to be a bit of a Platonist, like many mathematicians, about mathematics existing in a kind of Platonic realm, and in that sense being necessary, mathematical theorems being necessary. As Keith Ward would say, held in the mind of God. But which mathematical structures are instantiated in universes, then that does seem to be a decision that depends on the will of God. And God can instantiate whichever theory he chooses. I mean, it seems to me that he chooses to instantiate a theory which gives rise to this wonderful universe that we're in. So that's where I think I would say, what actually is the case in the universe is the existence of the universe and the laws that are are within it are contingent, because although God's being is necessary, God's will God can make choices. So what God decides to do is contingent.
Okay, so I thought I saw one more hand way back there somewhere. Did I? Okay, so let's make it really quick, and then we'll break. So yes, please go ahead.
Dr. Holder, I was wondering if, in principle, we can test for the multiverse, because I recall, I think George Ellis, the South African cosmologist, saying he couldn't think of a way of testing for a multiverse, and even in my limited understanding, we can't seem to think.
Well, I think I'm on pretty much the same wavelength as George Ellis on that, and George has spoken at the Faraday Institute in the past as well. He says that, there probably are more galaxies outside our, 13.8 billion light-year horizon. Well, inevitably, we're probably at least in a bubble of 40 billion light-years across, in which the universe looks very similar. And that seems to be an entirely reasonable extrapolation. But to extrapolate to other so-called universes within the same space-time, which are, many, many orders of magnitude further away, and from which no signal can even in principle reach us, that does seem to be, the height of speculation. And how that could be verified. Well, it can't be verified directly. I think the only kind of clue we can have is to do some of these kind of probability calculations and to calculate, given multiverse theories, what is the probability that that we as observers would be in a universe which resembles this one. And I think the argument that Father Javier was just referring to says, well, that's pretty unlikely. We'd be more likely to be in a single solar system type universe.